Welcome guys to a whole new video, and in this video guys we'll cover a forensic analysis series, and I'm going to show you guys how to create disk to disk image copies, or rather forensic image copies of Windows operating systems. In the world of digital forensics and cybersecurity, preserving data integrity is very important. So whether you're investigating a breach or building a legal case or simulating any insider threats, then the first critical move that you're supposed to carry out is creating a forensically sound disk image copy of the entire system. And in today's video, we're going to dive into the process of disk imaging on Windows live systems. So you learn how to make bit by bit copies of the hard drive, the same way professionals normally do it in terms of incident response, e-discovery, and also forensic investigation in legal cases. So we'll explore industry trusted tools like FTK Imager. I already have it downloaded in my machine. I'll attach the links in the description if you want to download some of the tools that I'm using over here. All the tools that will be used in this video are open source tools, so you can download them for free. So we're going to talk about how to create sector copies, talk about why hashing and write blocking is very important, and why it's important in maintaining a proper chain of custody in a legal forensic investigation. By the end of this video, you'll be able to create a forensic image copy of your Windows machine in a safe and legal environment without compromising the original data. So the first tool that we're going to use is Hard Drive Imager. And Hard Drive Imager, as you can see guys, is a professionally disk imaging tool solution, and it's very fast and efficient in terms of performing forensic imaging on your machine. So we are going to install it and run it as administrator. So the good thing about Hard Drive Imager is the ability to create sector by sector copies, and this is not particularly focused on the partitions in itself, but the entire physical disk, so that you can capture all the data. So in this scenario, it can capture everything, including deleted data, any slack space, or even any hidden system sectors that are within your system. So it supports a wide range of output formats, which we'll see after we install Hard Drive Imager. So I'm going to install it. And you are running this investigation in the assumption that this is a live system that we are running the disk imaging from, and all the tools that we are going to use can be utilized in a live system that is running on Windows. So we are going to run and launch Hard Drive Imager. And as you can see guys, this is the interface. It gives you a trial period of around 30 days, but it's a very simple interface where you can use it to create forensic copies. So in our case, we only particularly focused on creating a disk image copy, but if you want to restore an image, maintain partitions within your disk, or create any image data from the files that you have in your system, then you can use the other options. But in our case, since we want to create a forensic image copy of our machine, select the first option, and it will automatically analyze your hard drive, check all the partitions that are within your system, then list down all the partitions that are in your Windows system for you to create the forensic copies. So as you can see guys, if we check our host system, we can see that it's running on one partition, which is our disk C partition, which has a total of 89 gigabytes of storage and at least 63 gigabytes of free memory in our disk. So what we'll do is we'll select our partition, which is partition C, then we'll select next, and as you can see guys, R drive Imager gives you various file formats in terms of extracting your image copies, and as you can see, it supports a wide range of output formats and allows you to store most of the images locally within your machine or any external drive. So depending on your preference, you can choose any file format. In most cases, VHD format is supported by most forensic tools, and we can give it a name. Let's first of all specify where we'll store our image copy. Then we'll give it, we can just leave it to the default name, which is the C image.vhd. Then we'll select next. And right now it will give you the duration time, details about the image creation in terms of partitions. You can see the actual capacity and the used space, and it's using the NTFS file system, which is commonly used in Windows operating systems. And what we're going to do right now is click start, and this should start our imaging process. So in most cases, once the imaging process starts, you can leave your machine idle and wait for it to complete. Then once it's done, you can proceed to hash your image file in order to verify the hash values. So we'll give it some time to complete the image processing. This wraps up the imaging process using R drive Imager, and as you can see guys, we've successfully created a sector by sector copy of the disk, preserving every bit of data, including deleted files, any allocated spaces, exactly as it existed in the original physical hard drive. And the image is stored in our desktop folder, which is our forensic image. And as you can see guys, this is the image now, which is our C image file, which is ready for analysis, triage, and any long-term evidence storage. Next up, we're moving into one of the most widely used tools in terms of digital forensics, which is FTK Imager, created by AccessData. And this tool is a forensic powerhouse, which is lightweight, portable, and is very critical in terms of acquiring evidence grade in disk images. So FTK Imager allows us to create bit-by-bit copies of physical drives and partitions, and it also gives us an option to preview the file system, recover deleted files, and capturing memory without the modification of any data. It supports different image formats, including raw DD formats, E01 formats, and smart formats. And guys, if you saw before from hard drive imager, we also saw that it supported other different formats, which is VHD, VDI, and other different formats. So we can see that both tools gives you different format outputs for extracting the images. And the good thing about FTK Imager is it also has an inbuilt hashing feature, which can give you the MD5 and corresponding SHA-1 values that can help you verify the integrity of the image file immediately after performing data acquisition. So FTK Imager is trusted by law enforcement, incident responders, and other forensic operators when carrying out forensic investigations and extracting disk image copies. So now what we're going to do is we're going to install FTK Imager. Give it some time to install. Select the next option, accept. And once we finish, we're going to launch AccessFTK Imager. And this is the overall interface of AccessFTK Imager. So what we want to do right now is we want to extract an image copy of our machine. And in order to extract an image copy of our machine, select the files option on the top menu bar. Then we'll select create disk image. So it gives you an option to select the evidence source. In our case, since we are extracting an image copy from our physical machine, which is running on Windows operating system, we're going to select the first option, which is a physical drive. If you have a logical drive that is attached or mounted to your system, then you can select the second option. If you have an image file, then you can select the third option. So depending on your preference, but in our case, since you're talking about extracting a bit-by-bit copy of your entire hard disk partition, then we're going to select the first option, which is physical drive. Click next. And as you can see guys, it will automatically list all the drives present in your system. So depending on the number of drives attached to your system and the partitions in your system, you can select it from the drop down menu. But in our case, we only have one partition. We're going to select this partition. Then we are going to specify the destination. If you check below over here, we have a couple of options. And the first option, which is checked by default, is verifying the images once they are created. And this is where we are talking about the inbuilt feature of hashing that is within FTK Imager, and that's why most forensic investigators normally prefer FTK Imager, because it will automatically hash your image once the image creation process is complete, and it will give you the hash values for preserving the integrity of the image. So we are going to select the destination, and depending on the image type that you want, we know that most forensic tools normally support the raw DD format, the E01 format, AFF, and the smart format. But in most cases, I will prefer if you use the raw DD format or the E01 format. In this particular demonstration, I'm going to use the E01 format. So we click next. We can give it the case number, evidence number, then we select next. We specify a separate destination folder for our image file, which is separate from the storage location of our disk partition. And in this case, I have an external drive that is attached to my machine. I'll give it the name C drive, and I will leave the rest of the settings to the default settings, and we'll click finish. So right now we've added our image destination, which is a forensic image files directory, and right here is where all the image fragments of our physical drive will be stored in the E01 format. So what we're going to do is click start, and this will start the imaging process, which will take some time. So similar to hard drive imager, will give it some time to complete the imaging process. And just like that, our disk imaging with FTK Imager is complete. We now have a forensically sound image of the entire physical drive, along with the automatically registered MD5 and SHA-1 values. So if you can see, FTK Imager also verifies our image file and gives the corresponding MD5 hash values and SHA-1 values of the image file. The other tool that we're going to use to capture a disk-to-disk image copy of our entire hard drive partitions is DD, which in short stands for data duplicator. And DD is a command line utility that creates a bit-for-bit copy of the entire drive or partition. It is a lightweight, scriptable, and is available in every Unix-based and Linux, Mac, and even Windows operating system. So this tool can be used across multiple operating systems, and it proves useful in terms of versatility and reliability for forensic image capture across different platforms. So what you're going to do is you're going to capture the same internal storage. So we're going to run PowerShell as administrator and list all the current available drives that are attached to our system. And what we'll do is we'll try and check the specific drive that we want to image and extract the device ID of that drive. So run PowerShell as administrator. And the tool that we're going to use is WMIC. So WMIC, then we specify the disk drives, then we'll list them briefly. Then the format that we're going to specify for the drive listing is a list format. So basically we're trying to list all the drives that are attached to our system, and we'll extract the device ID so that we can use it on data duplicator so that we can extract the forensic image copy. So once I press enter, as you can see guys, we have the device ID, and currently we have only one drive that is attached to the system. If you have multiple drives, then WMIC will list all the current drives that are attached to your system. So this drive has 3 partitions. You can see the respective size that is given over here. We have the device ID. So what we're going to do is we're going to copy this device ID. Then we'll navigate the directory where data duplicator is stored. So right now we're in the current directory where data duplicator is stored, and what we're going to do is we're going to run the command, the / then dd exe. So right here we'll specify our device ID. Specify the output file where we'll store our image file, which is the folder that we created on our desktop. Then we give the image name C drive, and we'll use the raw DD format. So remember, with our imager we use the VHD format. For Access FTK Imager we use the E01 format, and in this case for data duplicator we're going to use the raw DD format. All of these formats are supported and can be used and attached in various forensic tools out there, so most of them are supported. Depending on your preference, you can choose the one that you want to use for your case investigation. So we've already specified the output file. We're going to name it as cdrive.dd. Specify the block size 512 kilobytes. Denote the size, and we'll show the current progress that is happening during image extraction. So basically what you're doing right here is you're calling the tool, which is a data duplicator executable. We've specified the input file, which is the device ID of our physical drive. Then we've specified the output file, and this is the storage location for a forensic image copy. And we've given the name C drive with the raw format DD. Then this one is the block size, in which in this case the data is read or written in 512 kilobyte chunks. Then we specify the size so that DD can report the size of the source drive. And finally, we've specified the progress option to show the live progress during imaging. So this is in the case of the block counts, the size copied, and it will showcase this during our image extraction. So right now what we're going to do is press enter, and we'll give data duplicator some time to create the forensic image copy. Remember, the entire storage size is about 89 gigabytes. So just to confirm, and this is the free memory in our disk. So we're going to give data duplicator some time to extract the full forensic image copy before we can view the image file. So since we don't have enough storage space in our machine, the process was cut out. But basically, if you want to extract a forensic copy of your machine using a data duplicator, this is the command that you can use, and it gives you the number of records in and records out. And as you can see, our disk storage is running a bit low. So for the final step, just to verify the file hash, we're going to use a tool called getFileHash in order to preserve the integrity of our image file. Then we'll specify the directory where our image file is stored. Then we will specify the algorithm in this case you may decide to use any algorithm that you want to use. In my case, I'm going to use MD5 algorithm. Then I'm going to provide the format for presentation as a list format. So what you're using is get file hash in order to compute the file hash of our created image file, assuming everything was successful. Then we specified our algorithm, which is MD5, and the format that we're giving is a list format. Press enter. Then we give get file hash some time in order to compute all the file hashes. And there we have it, guys. We have our computed MD5 hash value for our image file, which is the hash given over here. And before we wrap up, I want you to remember, guys, that disk imaging is the first irreversible step in any forensic investigation. You're supposed to get proper authorization from any law enforcement agency before you perform any data extraction from systems that you don't own. In most cases, I would advise most forensic investigators to make sure that the device that is under investigation is isolated and all the forensic procedures are documented as per the chain of custody that is given. So today, guys, I showed you 3 reliable options that you can extract disk-to-disk image copies in Windows operating system. I've showed you how to use hard drive imager, how to use AccessData FTK, and I've also showed you guys how to use the CLI interface from data duplicator. And in this case, you've seen how various tools extract forensic copies and give various file formats for the image files that are extracted.